I'm about to introduce the Karamba3D team. We have with us today George, Clemens, and Matthew, who will be discussing interoperability for structural engineering workflows and collaboration. So let's welcome them on stage. Welcome, guys. How are you?
Hello.
Hi.
Fine, thanks.
I'm good.
All right, I'll share your slides and the stage is yours.
Okay. Thank you, Sander. Thanks for having us. I will be talking about integrative workflows with Karamba3D and the current developments on it. So I'm here with Clemens Preisinger and Matthew Tam. And first things first, what is Karamba3D? It's an interactive parametric engineering tool. It allows finite element analysis embedded in the Grasshopper and Rhino environment, where you can parametrically use optimization algorithms like Galapagos or Octopus or Wallasey. Because Karamba is usually at the beginning of a design process, it's crucial for us to provide good interoperability connection to different software packages. And that's mainly the development right now. So in the Karamba3D version 3.0, work in progress version, how you can get access to it, I will tell you after the demonstration. The main developments are the load case combinations, which let you define how, in detail, how loads interact with each other. Then there is the BOM toolkit available at our GitHub repository, connecting also to a lot of other software packages. And I'm going to talk about mainly about the export to the structural analysis format, SAF, which allows to convert the model to an Excel file and share those, and also the export to the Speckle object, and also transporting that to a Speckle stream. So I've prepared a short demonstration. The first thing the first small little feature is the new Karamba toolbar tab at the top of the Grasshopper window next to the Speckle one, which replaces the settings components, where you can set your units you're working with, also set component visibility, for example, the parametric UI and the work in progress components. And for that examples, I used an example from our website. It's an old example. You can find it here. It's called Input Curves and Analyze Structure. So the first thing I want to show you is the Speckle export. You can find the component at the Export tab, and you also have to enable the Show WLP components. You have a lot of export options. You can add information to the model. The default export path would be to your desktop with a default name, which is Karamba3D model.xls. Then you can find the Excel file on your desktop. The outputs is the provided Karamba model, of course, and some information about the export, like what elements and how many elements were exported, as well as error messages and warnings. So if I hit the toggle button, it will export in just a few seconds. So now it creates an Excel file, and there you can see it displays also a warning, which is because we're still working on it, or I'm still working on it. If the model contains results, so it was calculated, we right now have not yet implemented the export of results for shell elements. So now we have our Excel file, and we can head over to Skier or Bluebell or EVS Statica. Each of these softwares
Sorry, Georg.
provide. Yeah.
Your mic is rubbing something against your t-shirt or something.
Hello?
Try to speak.
Okay. So now we've opened Skier and imported the model. And as you can see, the full structure is available, and you can access the properties provided from the Karamba3D model directly in here. And it's a very straightforward process. You only have to hit calculate, and this is fast forwarded, so because it takes some time, and the results should be within tolerance, the same as with the Karamba model. So the next thing I want to show you is another export option, which is the Speckle export and import. So you have these conversion components in the export tab, where you have to provide a valid Karamba.
Georg, sorry, I think your
Yeah.
mic rubbing.
I'm not moving. Okay.
Yeah.
So where was I? So this will convert the Karamba model to a Speckle structural analysis model, which you then can deconstruct using the provided Speckle components into all of the small elements the model contains. And we hope to not only share, transport, and store models using this approach, but also be able to modify models using the way through Speckle. So now we could use a descent component from Speckle to push the structural model to a Speckle stream. And for that, you only have to provide the model information and some stream. I've placed the stream information earlier on top of here, so I only have to connect those. And if I click it now, it will send the Karamba model to a Speckle repository within a few seconds. And now anyone with the stream information can pull that information and work with it. So now we take a look at the Speckle model in the browser, just to verify it is really there. And then we just want to receive it again in the Grasshopper file. So the Speckle model is here, and now we can reconstruct the Karamba model using the import component. To verify that the previous model is valid, I just connect it and view it without using the Speckle stream for now. But as you can see, it creates a valid Karamba3D model, which you can then analyze and also visualize using the analyze component and then the model view and beam view component. The only difference between those models is, as you might see, is the yellow colored line loads from the previous model, and that's because it's an old example which uses deprecated but still supported line loads, and with the conversion, it gets converted to the current line load type. So now I've received the model from the Speckle stream, and everything works as it should. So now we can head over to something like eTabs, which is supported by Speckle or has a Speckle connector. And for that, we just create a blank model. And then we can close the plan view because we don't need it right now. And we can head up to the tools where we can find the Speckle connector. Within the Speckle connector, then we get the right stream and the correct branch where we last pushed our model and we want to receive the model. And this is again fast forward as with the calculation, because eTabs as well as Skier and all of those software packages take a long time to reinterpret the models. And as you can see, it is still work in progress. I still have problems transporting the right units. But for now, we just use the perspective toggle button from eTabs to fit the model on screen. And again, the same, it's just the same straightforward process. All the information, all the properties, all the materials and cross-section from the Karamba model are already inside the model, and you only have to hit Analyze. And again, now we only have to display the undeformed shape, but if we hit Analyze, you will get the results for the reaction. So this is the calculation log, and there you see the deformed model and the undeformed model, as well as the reaction on the supports and the section forces of our beams. And if we double click that, we can change what we want to display, like moments or axial forces. The nice thing about using Speckle is that it handles the conversion into all of those software packages. So from here, we can also just go straight into Revit and use the exact same approach there. By just pulling our model from the Speckle stream into Speckle, it will rebuild the model. And as you can see, we have missing types. That's because we are working on a live table that translates the names of the cross-section into Revit names for cross-sections. So that should also be fixed at one point. And as you can see, it rebuilds the model in Revit with all the necessary information and all the corresponding and provided cross-sections. And if you have analyzed the model, you could also view the analytical model in here. So that's it for the demonstration. And as I already mentioned, Karamba3D is an ongoing development. Every few weeks, or at least once a month, Clemens will update the installer for Rhino 6 to 8. And you can find the latest build with bug fixes and new features on our GitHub repository with the name of Karamba3D Nightly Build. And yeah, if you want to check it out and test it, you're very welcome. And if you find bugs or missing features, please let us know. And yeah, that's it. And if there are any questions, we would be glad to answer them.
Thank you, George, and thank you all for being here. There are no questions, but there might be in a bit. And if so, there will be in the chat. We will have to move to the next session, but thanks a lot. And also glad you made the mic work in the end.
Yeah, I don't know what's wrong.
All right, we have one question. I'll bring it on stage.
No, it only works within Grasshopper, so you have to pull it first. I don't think Speckle provides that possibility.
But maybe it's a good feature to add onto the roadmap for Speckle as well.
All right. If there are no more questions, then thank you so much again, and we'll see you guys very soon.
Thank you. Goodbye.
Thank you too.
Bye.
Bye.